This is a worked example on how to do long division with polynomial functions. So the first thing that we want to do is we want to actually set up the equation, similar to how we would set up any division problem, well, long division problem. You can draw this bar and then place your two functions. Okay, so the first thing I want to ask myself is, I want to look at this leading term of what I'm dividing, or what I'm dividing by, and then ask, what do I multiply it by to get 3x squared? And there are no tricks here. This is just going to be x times 3x squared x times 3x equals 3x squared. And so I take this value of 3x, and I can just write this on top of the division bar. Okay, so let me erase my scratch work. So I know that x times 3x will be 3x squared. So now I can take this value of 3x and multiply it by the entire quantity x minus 1. So let's go back to my scratch work. And I can see that if I multiply this out, I will get 3x squared minus 3x. And so we actually want to write this below the next, below the first two terms of the polynomial we're dividing. So 3x times x minus 1 is 3x squared minus 3x. Now, like we do in long division, we want to subtract this off. But you need to be careful here because we're subtracting off an entire polynomial and not just a single number. So what we really want to think about is multiplying this quantity by a -1, and then we're just going to add through the columns. And so what you'll see a lot of times is people say this thing called flip the signs. This is just expressing that idea of multiplying by a -1. So even though I erased a little too much, what I will do is I will flip all of the signs. So 3x squared is positive, but we're now going to make that a negative, and then negative 3x was negative, but we are going to make that a positive. Now we can add down the columns. So 3x squared plus negative 3x is 0. So actually, I'm just not going to write anything. And then negative 2x plus a positive 3x equals x. Now, like we do in standard long division fashion, we can bring down the next term. And so the new term we're working with is x plus 1. And so let me actually switch colors here, because now we're going to repeat the process over again. So I'm going to ask myself, what times x gets me to x? Well, it's just going to be 1. So x times 1 equals x. I know that scratch work is not very exciting, but you can write down the plus 1 on the top bar because the 1 we're multiplying is positive. And then this 1 term we're going to multiply by the entire quantity of x minus 1, and that will get us x minus 1. I know it's not the most exciting problem in the world. And then we're going to go to subtract this off. But remember, we don't want to just tack a negative sign in the very front. We're multiplying the entire quantity by a -1, and so we can represent that by flipping the signs. And so this x becomes negative, and this 1 becomes positive. You'll tend to know that you did this sign flip, and oh my god. You'll tend to know that you did the sign flip, and you did the choice of this correct if everything cancels out nicely, at least in the first column. There's no guarantee that like the other things will cancel nicely, but as long as you have that first column canceling perfectly, you'll know you made the right choice. And so again, x plus negative x is of course 0, and then 1 plus a -1 is going to be 2. And so we're not quite done yet. We always want to express our final answer in that form of p of x equals d of x times q of x plus r of x. You should get in the habit of writing out your answers in this form. And so let's actually do that. So our original polynomial p of x is the larger one that was getting divided. So I can write 3x squared minus 2x plus 1. Now, d of x is the thing that we divided, or the term we used to divide. So it's going to be that x plus 1 term over here. So I can write that as, in parentheses, x minus 1. Then q of x is the result. So that's what we wrote on top of the division bar. And so that will be 3x plus 1. And then r of x is just the remainder. And the remainder is whatever we have left over down here. And so I can simply write that as plus 2. And then you can actually go through and check that this answer is correct by expanding out this term, multiplying everything out. And if you get the exact same thing as on the left side of the equation bar, you'll know that we have done it correct. And so that is a easy example on how to do polynomial long division.